Hello and welcome. So today I'm going to be solving this predicted chemistry practical WAEC 2026 paper, right? For chemistry students that are taking internal. Have this value, right? So the acid has 5.60 centimeters cube, and then the relative density is 1.84, while the purity is 98% per dn cube. Then the base, which is the sodium hydroxide, is 25 centimeters cube that you use your pipette to measure, and then the mass per dm cube is 4, right? Okay, so now let's see, how do you carry out this calculation to get the volume of the acid without using the table? Remember the table where you have your first reading, second reading, your initial reading, your rough reading, and the rest. Then you find the average value of the volume of the acid, which according to standard should range between about 12.10 centimeters cube to 12.50 centimeters cube. All right, so let's see how we are going to get this value out from this place, right? Okay, so how do you start? The first thing is that you find the molarity of the stock acid. So molarity of the stock acid, which is this H2SO4, will give you percentage purity, right, times the density times 10, all divided by the molar mass of the acid, which is H2SO4, right? Okay, so giving the values here, percentage purity is 98 times density is 1.84 times 10, all divided by molar mass of tetrazosulfate 6 acid is 98 grams per mole, right? So you have 98. So when you divide this take away this, multiply this by this, it's going to give you what? By 10, it's going to give you 18.4. Okay, so by unit, we have 18.4 mole per what? dm cube. Okay, now the next thing we are going to be looking for will be the dilute what? Molarity. So we're going to be using the dilute formula, which says the dilute formula says M1 V1 is equals to M2 V2. So is this M2 we are looking for? Finally, the molarity of the acid, right? So it will give you M1 V1 all over what? V2. Now, M1 is this value we've gotten, 18.4, times V1 is the volume of the acid, 5.60, divided by V2. Everything we are doing is in DMQ, right? So we'll now use 1000 centimeters cube or 1 dm cube. All right, so let's multiply this and divide it by 1000. Where's our calculator? Okay, so we have 18.4 times 5.60. So we have this. So we divide by, we have 103.04 divided by 1000, and that will give us, divide by 1000, and that will give us 0.103 mole per dm cube of the acid, right? So we can call this MA. All right, so this is how we get the molarity of the acid finally in this our calculation. So if you have gotten this, I will erase it and then we go on to finding the molarity of the base, which will also help us to finally find the volume of the acid used. Okay, so let's see. Let's take this off the screen now. Let's take this off. Okay. All right, so let's find the molarity of the base. For the base, sodium hydroxide, so the molarity, as a concentration, is mass, the molar mass, the mass all over what? Molar mass, right? So the mass given is 4.0 all over the molar mass of sodium hydroxide is 40, right? 40 grams per mole. So when you divide that, you have 4 divided by 40. That will give you 0.100 mole per dm cube. Mole per dm cube. All right, so let's not forget our MA was 0.103 mole per dm cube, right? So let's put it there because we're going to be using it. So this is our MB, 0.100 mole per dm cube, right? Okay, so let's see. The next thing we are going to do now is to recall the formula that says MAVA all over MB VB and is equals to NA NB. So we know this formula, right? Okay. All right. So now, before we can complete this formula, we know that MA, we have the value here. MB, we have the value here. VA is what we are going to be looking for, while VB is 25 centimeters cube. How about NaNB? That will be gotten from the standard equation between the reaction of S2SO4 and sodium hydroxide, right? Okay, so remember, when you are solving this, you must give the balanced equation. You must give what? The balanced equation. Yes. So when you are solving this, you must give the balanced equation. Now, in the balanced equation, this tetrahydrosulfuric acid is aqueous. Even their state, you must also indicate, right? So when these two react, you have Na2SO4 plus H2O. So what is left to be balanced? Sodium here appears 2, so we can put 2 here. Hydrogen becomes 4, so we put 2 here. So this is balanced. So this is also aqueous. Why this is what? Liquid, right? So this is liquid. Water is liquid. Okay, so this is the balance equation. Now, from the balance equation, if you look at the mole ratio, you see that tetraosulfate here is 1, while sodium hydroxide here is 2. So this is Na and this is Nb. Okay, so if we put them into this formula now, we'll be able to find Va, right? Because all other things are given. All right, if this equation is taken, I would like to wipe off this so that I can have space to work this out. Okay. So let's see how we are going to make Va the subject of the formula. So making Va the subject of the formula, that means this will multiply this and this will multiply this. So we have Na Mb Vb all over this and this Nb Ma. Okay, so let's substitute value. Na we know is 1. Mb is this value 0.100. Vb is 25. So we have 25 all over. Nb is 2. Ma is this value 0.103. So let's finalize it. So we have 0.1 times 25. We have 2.5 divided by this one will give you 0.206. All right, so let's have 2.5 divided by 0.206. So this is going to give you 12.14 centimeters cube. So this is the Va, volume of the acid, the average volume of the acid, right? Now, remember I told you from the start that the average volume of acid starts from what? 12.10 centimeters cube to 12.50 centimeters cube. So in the standard exam where you will do the practical in your lab, the value of the acid at average should give you from 12.10 to 12.50 centimeters cube based on this calculation. So this is how teachers used to know the value of the acid, the average volume of acid to use in your practical. they will first solve this using the information given, all these relative density, purity, the volume of this and that to get this, exactly as I've done it so. So in case you are having doubt of the volume that you are seeing in school, work it out this way. You will know the volume that you can use, and then you'll be sure. This is a kind of a way for you to know that, okay, I'm sure this is the volume that I should have in my chemistry exam. I wish you the very best. The next video, I'm going to do the table, the titration in tabular form, and do other calculations that are involved. I'll see you in the next video. Remember to follow, remember to like, remember to subscribe, and share with your friends, share with your family and friends. You that have seen it now, share it to another person. Let that person also benefit the way you are benefiting like this. I love you. I'll see you in the next video. Bye.